Hey guys, Math 8, we are ready for Chapter 4, Section 3. We have just finished solving equations that involve cubes and cube roots, and the rest of this chapter pretty much deals with all types of exponents. So here we go. You can see here that today we are doing exponents on a product. That means a product is when you're multiplying. So this is what happens to exponents when you're multiplying stuff together. But before we do that, we're going to talk a little vocabulary. So right here, I have a term, right? This is just a term, and I think it's important to know the parts of the term. So, of course, we have the 3, and we have the 2, and we have the x. So, the 2 is something we've talked about before. I hope you know what that is. It starts with a C, and it ends with an coefficient. Right? The 2 is the coefficient. Every variable term has a coefficient, right? The x, I'm going to get to the x in a minute. The 3 is the exponent. Now, the x is a variable, but in this case, I'm not talking about it as if it's a variable. I'm talking about it as it is the thing under the exponent. And the thing under the exponent is called the base. The base is what is affected by the exponent, or whatever the exponent is on is called the base. And in this case, the exponent is on the x. So I have an example over here that does not have a variable, right? I have 2 to the 5th power. In this case, the exponent is the 5, and the base is the 2. And there is no coefficient, because a coefficient is only on a variable term. Now, we have 3 different ways that we can write this expression, this 2 to the 5th. It can be written in what's called expanded form. Expanded form is really just when you use the exponent. So expanded form would look like 2 times 2 times 2 times 2 times 2. Expanded form is what the exponent is telling you to do. Multiply the 2, or the base, times itself 5 times in this case. Then we have exponential notation. All right? Exponential notation is when you write it with an exponent. So in this case, that is the way it's already written, 2 to the 5th power. When you write it with an exponent, that is known as exponential notation. And last, but not least, decimal notation. Decimal notation is when you, I guess I'd say you get the answer. And so in this case, in this case, that would be 32, right? 2 times 2 is 4, times 2 is 8, times 2 is 16, and times 2 is 32. 2 to the 5th power is 32. So those are 3 different ways we might write an exponential expression: expanded form, exponential notation, or decimal notation. All right, so our main goal, this is our main goal for the rest of Chapter 4. When you do operations like adding or multiplying or dividing, I guess adding, subtracting the same. How does that affect the exponents? What happens to the exponents when you do operations on terms that have exponents? And we're going to look at that. Like if I multiply 3x squared y times 5x to the third y, what would the answer be? Or if I multiply 2 to the third times 2 to the fifth, how does that affect the exponents? We're going to come back to those two in a second. You can take a guess right now if you want, or maybe you know, but we'll come back to it in a second. Let's look at the rule first. So our first rule of like 5 different rules that we will learn, our first rule is this one right here called the product of powers. A product is when you multiply, and powers are exponents. So I am multiplying things together that have exponents on them. And let's look at what happens. The easiest way to look at what happens is to write this problem out in expanded form. We all know what 2 to the second actually equals. It equals 2 times 2, right? That's what 2 to the second really means. And we know what 2 to the third really means. It means 2 times 2 times 2. Now, I am multiplying these things together, right? I am multiplying these things together. So what I really have here is I have 2 times 2 times 2 times 2 times 2. Or that would be 2 to the fifth power, because that is 5 2's multiplied together, right? That is what the exponent 5 means. It means multiply the 2 by itself 5 times, which is what I have here. I have 5 2's multiplied together. So my question would be, you see the exponents here? What actually happened to the exponents? How did multiplying these two things together affect the exponents? Well, here's what happens. When you multiply two expressions with the same base, very important, they have the same base. What do you do with the exponents? You add the exponents, right? That's how the 2 and the 3 over here, that's how they became a 5. So in the future, we do not have to write out this whole thing, 2 times 2 times 2 times 2 times 2. We just know to add the exponents when they're on the same base. So let's do a few examples and see if we follow this. What is x to the third times x to the fifth? Well, that would be x to the 3 plus 5, or x to the 8th. When I am multiplying two things together that have the same base, right, the x is the base, then I can just add the exponents. What about 3 to the second times 3 to the fifth, right? Now the 3 is the base. So I don't multiply the 3's together. No. When I multiply two things together that have the same base, all I do is add the exponents. This would be 3 to the second times 3 to the fifth, which of course would be 3 to the seventh. Right? Think about that, you guys. The most common mistake is to want to make this, when I multiply these 3's together, the most common mistake is to want to make it a 9. But it's not. 3 to the second is 3 times 3. 3 to the fifth is 3 times 3 times 3 times 3 times 3. What I really have here is 7 3's multiplied together. So 3 to the seventh. I don't have a 9. All right, let's look at a more difficult one. 5x to the fourth times 4x. Now let's think about this. 5x to the fourth is really 5 times x times x times x times 4x. That is 4 times x. So what I really have here is a bunch of x's multiplied together, right? Bunch of x's multiplied together. But also, I have a 5 and a 4. Oops. So what I can do is I can multiply the 5 and the 4, which is 20. How many x's do I have? It looks like 5 of them. This would be 20x to the 5th. Do you see how really I just multiplied the 5 and the 4 together, but the x's, I added the exponents and got x to the 5th. This x at the end really has an x to the 1st. When the exponent is 1, we don't write the 1. So what I really have here is 4 x's and another x, 4 x's and another x, giving me 5 x's multiplied together. 20x to the 5th. And before I do letter D, let's look at what it says here. So in general, when you multiply terms together, you can tell from the last example I just did, you multiply the coefficients together, like I did up here. I multiplied the 5, where is it? And I multiplied the 4. But you add the exponents on any common variable. I added the exponents together. So how would that look over here? Well, if I was doing this example, I would multiply the coefficients 3 times 5, but the x, I would add the exponents 2 plus 4, and for the y's, I would add the exponents, which is 3 plus 1. So my final result is 15, x to the 6th, y to the 4th. Do we follow that? Multiply the coefficients, but add the exponents when they're on a common base, in this case, a variable. Real quickly, let's go back to the beginning here. Where did I do that? Back here. And now see if you can get the answer here without me telling you. Right? Maybe you pause the video and you answer it, and then you see if you got it. All right, so this would be 3 times 5 is 15, and I've got x to the, let's see, I'd add those, x to the 5th, and I've got a y to the 1st and a y to the 1st, so when I add those, it would be a y to the 2nd. Now, I'd like it if you could go right to the answer like that. But if you need to write it all out, oops, you could get the answer by taking this thing and going, that's 3 times x times y. And you could take this thing by doing 5 times x times x times x times y. And then you could get the answer, right? So 3 times 5, that's the 15. I've got 2 x's there and 3 x's there. That's the x to the 5th. And I've got a y and a y. That's the y times y is y squared, y to the 2nd power. And over here, what do you get here? Well, you've got 3 2's and 5 2's all being multiplied together. All being multiplied together. Do you have to do this? No, you don't have to do this. But really, you have 3 2's and 5 2's, and they're all being multiplied together. That is 8 2's being multiplied together. That would be 2 to the 8th power. What's the short way to get that? Just add the exponents, right? All right, one last thing, and we're ready to move on. And that is this letter D example here. So here's the deal with letter D. Most people think that this should be 10 to the 5th. Sometimes they even say 10 to the 6th. But you guys will not be tricked, right? Here's the trick. The exponents the exponents are not on the same base. The 3 is on a 2 and the 2 is on a 5. When they're not on the same base, you can't use any trick for exponents. You just have to use PEMDAS. There is no trick with the exponent. You have to figure out what 2 to the third power equals. That is 8. What 5 to the second power equals. That's 5 times 5, 25. And then multiply 8 times 25, and you get 200. No trick with the exponents when they're not on the same base. All right, we are ready to move on and just see some things you might be able to do now. Letter E, you don't have a partner. We probably won't do this. Maybe we'll do it in class when you're there. Can you determine 3 or more ways to write a product using 2 as the base that would give you the same answer as the problem below? All right, here's the problem below. 2 to the second times 2 to the 10th. That would be 2 to the 12th, by the way. Can you give me 3 different ways to write a product whose answer would be 2 to the 12th? We want this to be the answer, but we don't want to use this problem. We want you to write 3 different problems whose answer is 2 to the 12th. Let's see, how about 2 to the 4th times 2 to the 8th? How about 2 to the 11th times 2? Huh? How about 2 to the 6th times 2 to the 6th? All 3 of those would be 2 to the 12th. Huh? I'm almost done. All right, what if I ask you to write example A out in expanded form? Could you do it? It would be 2 times x times x times x times x times x times x times x. That's right, there are 7 x's multiplied together thanks to this exponent. Times 5x to the 4th, that'd be 5 times x times x times x times x. Or in exponential notation, that would be 10x to the what? 11th, right? How about the next one? Let's see, that would be 3 times x times y times y times y times 7 times x times x times x times x times x, which would be, let's see, 3 and 7 gives me 21, and I've got an x here and 5 more x's here. That is x to the 6th, and then I've got these 3 y's here, so y to the 3rd. Do you have the last one figured out? The last one would be x times y times, right? There's that part. Times x times x times x times y times y times y times y times z. That's what that one means. So what's my final result? Well, there is no coefficient, or the coefficient is 1. But I have 2 x's and that's x to the 5th. I have a y and 4 more y's. That's y to the 5th. And I have a z. All right. Last thing, I think. Can you fill in the blanks? So you're going to have a couple homework problems like this. Let's see. What would go in this blank right here so that when I multiply these together, I get 21x to the 8th? So what I notice is that the 3 and the 7, gives me the 21. But what gives me the x to the 8th? That would be, let's see, I have x to the 5th. I have x to the 5th, so I need x to the 3rd here. if I want x to the 8th? I think it would have to be a 3, right? Because when you're multiplying terms together, you add them to get the answer. The exponents get added. How about down on the second one? You got the second one here, letter B. I see that the 2 and the 9 gives me the 18. Ooh, tricky one. Tricky one. You think you got it? What do you think? What number plus 7 would give me 4? Something plus 7 needs to equal 4. Oh my gosh, it's a negative exponent. How about -3? Y to the -3rd. And before this chapter is over, we're going to learn more about negative exponents. But for today, we are done. Good luck on the homework. I'll see you next class.